don't know if you can hear me or see me, but I'm here. Hope you're having a good Wednesday. Oh, thanks. Who is that, Hunter? All righty. Yeah, I got a tie on. Let me mark you in. Everything going okay for you, Hunter? It's good to hear. Let's see. Indira, are you there?
Yes, I'm here.
How are you doing?
Good. And you?
Good. I have some watermelon here, and I'm going to be chunking on that.
Oh, watermelon, they are my favorite fruit.
Lillian, are you here? Lillian, are you here?
Yes, yes, I'm here.
Okay. Calzada, Rebecca?
Yes, I'm here.
I got you marked in. All right. Okay. Jamie, are you here? Nikki?
I'm here.
Hi, Nikki.
Hi.
See, Edith, are you there?
I'm here.
I got you, Edith. Emma. Is Emma out there? No, Emma?
Yes, sorry, I'm here.
Okay. Rosio. I got you, Rosio. Ryan?
I'm here.
Got you. Monica?
I'm here.
Good. Reba?
I'm here.
You still hanging here in Texas, all right? Everything okay?
Yeah.
Edith, do you have a question? Did you guys get the car problem already?
Yes.
Okay. Marissa, are you there?
Yes.
Did anybody I missed so far? Well, let me get started. Sharon, are you here now?
Sir, good evening.
Good to talk with you. Good, good, good. Okay, so I think I have everybody calling for here. If I don't, oh, Amanda, I don't have you.
I'm here now. I was having trouble logging in.
Let's see, Amanda. Gotcha. Edith, what's your question? Can you talk? Edith, can you talk? Eric, I marked you in. Does anybody know what Edith's question was?
He wants to know if the discount comes from the original sale price.
Does it? Does anybody know?
No, it
I'm-
doesn't. It comes from the
No.
end.
No, it doesn't, Maria.
Yeah, it doesn't. It's just in the process of negotiation. Nobody would ever make a deal like that. You get at the very end and then say, all of a sudden you say, you're down to like pennies. You say, oh, I want, a percent off the whole price. It happens at the moment. So the answer is to that is no. It happens in the sequence that is shown. Has anybody completed it yet?
Yeah.
Lillian, do you have my phone number?
No, I don't. Yeah, I think in the syllabus. Correct?
No.
No.
I have a
If
question.
I give you
In the
Lillian, time out. If I give you my phone number, can you text me the amount that the car cost that you came up with? Not the payment, but the car cost. Can you?
The cost of the car, yeah.
Okay. This is the end cost. That means what you figured out at the very end it was going to cost, right?
Oh, the cost. I got the payment, but I didn't get the Oh wait, the PV?
Yeah, you have to get the cost in order to make the payment.
Yeah. Okay, so yeah, I got that, I think.
Can I give you my phone number? That's where we're
Yeah.
at.
Yeah.
Okay. Text me what you got for your answer. I'm 214-808 7728.
Okay. All right, I can do that.
Okay. I'm waiting for it, and I just want to see what you come up with.
Okay, you should have received it.
It's not correct.
No? Aw. Okay.
Not even close.
What?
No,
I'll take a look at it again then.
it's not. Not. Anybody else have it? The car problem done.
I think I do. I'll text you. It's Amanda.
Is that? Is Amanda just text me right away? Sharon, did you have a question?
Yes, so regarding the homework,
What homework? The car problem, you mean?
mhm.
Yeah.
Should I do the additional questions attached to the homework as well for submission?
I'm not sure what you mean.
Like you gave us a page full of the tutorial and the videos and everything.
Yeah, you don't. I don't need that back.
Okay.
I've already given you that, so I don't. No, you just need to do your work and stuff.
Okay. So do you want the answer to the final payment texted to you right now?
Just no, no. I'm just asking that one person.
Okay. 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 Get you.
Amanda, was that you that sent me that?
Yes.
I need the cost of the car, not the payment.
Yeah, I put the cost of the car on there at the bottom. Do you see it?
Oh, that's not right.
No?
No, how? There's no way you can get the right answer and have that be the cost of the car. You said the car costs over 19,000, right, Amanda?
Well, I just added, I put that's what I got for the payment, the first number times 48. And then that's what, I mean, I just did it quickly because I didn't have the cost of the car on my original work. I only had the payment. So I times what I got for the payment, which is that first number times
Wait,
48.
Amanda, the cost of the car has to be in your program that you did for your calculation.
Yeah, that's the cost of the car with the interest on it.
No, that's not what I'm asking for. I'm asking for the cost of the car.
All right, I'll send it to you again.
No, the cost of the car, Amanda, is just what the car cost when you subtracted everything. So who's 2117?
That's me.
Oh, Amanda, well then you are precisely correct.
Okay. Well, I was giving you the last one I sent you was with the interest. So, all right, we're on the same page.
Mm-hmm. Now, the reason why I ask, because Amanda has it right in every respect. She also calculated what the car would cost after the payments, which is extra information that I didn't even ask for. But that is very interesting. So in order for someone to do this problem, you have to have.
I think 20 years ago when I was buying a car, that was probably important information to have too. So just FYI. Maybe it can be extra credit.
Yes. What I'm saying is, in order to do this problem, we have to know what the final cost of the car is before we can add it into the computer. So all your costs must be subtracted first, and then at the very end, a percentage is taken off, and I give you what you multiply it by. Then I say that has to be rounded up to the nearest dollar. The payment is not rounded up to the nearest dollar. The end payment is to the penny. So if anybody has a question or needs a study buddy, I would beg Amanda to be that person because she's right.
I already have a study buddy.
There you go. Who is that, Amanda?
Nikki has claimed me.
Okay. Maybe somebody can claim Mickey then. All right. May I ask or answer any other questions for anybody?
Professor, can you little bit tell me about the additional discount, 0.848%?
Well, whatever amount of money you got uh, mm, figured out on the subtraction of all the costs of that car. At the very end there's a cost. And then Jose says he needs a little bit more money off. And they take that percent and multiply that to the bottom line cost of the car. That means where you finally got it negotiated, whatever that number was. And you take that number, multiply it by, and I gave you the percent also in decimal form so you could do it in your calculator. So you take that number, multiply it by the 0.00, whatever it is, 85, you'll get a number and you got to round that to the nearest dollar, and then you're done. And then you can put it in the calculator.
Thank you.
So Hunter, I think, let me check. Let me see. What percent did we say you're supposed to get off on this vehicle? No. What percent are you supposed to I'm not asking for the interest rate. I'm asking for the percent of discount.
0.845.
No, what is the
Oh.
problem say? It says point what?
845%. Oh,
No, it says 0.00845. I typed it out in there.
Oh
right?
yeah, it's there. Yes.
So Hunter, your number is without that discount. You got to take that discount and then you'll be home free, okay? No. It's not what it says. It's off the base of the car. Because if it was interest, it wouldn't say dollars. Okay, so I hope, Hunter, that helps. Does that help a little bit? Are you there, Hunter? So you got to take that amount and multiply it by that percentage, and that's got to be rounded up to the nearest dollar, and then you subtract that. Okay, so Hunter, does that help a little bit then maybe? Okay. All right, so we're back to to the book. I mean, it's an interesting problem. So hopefully you can get here. We are 3.1 quadratic equations. Can you all see this?
Yes.
Okay. A quadratic equation involves what you see in front of you, f of x equals a to the x squared, b to the x plus c. It's not a cube, it's a square. Now, if we go to our calculator and we put in a simple equation, let's go to y equals. And let's put in x squared plus 2x plus 1. Yeah, let's just do 1. And graph it. This is what you get. Since the x squared, looking at the original equation, is positive, it means it holds water. If it was negative, watch what happens. This is negative, not this. We're going to put in the x squared. We're going to put in the plus 2x. We're going to put in the plus 1. And we're going to graph. They're both going to graph. Let's see what happens on this one. Notice since we had a negative in front of the x squared, you can see we have a negative in front of the x squared. It does not hold water. What I mean by that is, if you look at the graph, the tip of the graph, which we call the vertex, is the highest point in the graph. We call a max. In the blue one, the tip of the vertex is at the very bottom of the graph. We call that a minimum. Am I making sense so far to everyone or anyone?
Yes.
Okay, so again, if you have a negative, like in the red one here, that's this one that I'm blinking on, it will be a maximum. The blue one's a minimum. Back to the book. Now, this is a function that they have built. If you look at it, inside the parenthesis, just above solution, you have x minus 3. To make that 0, what number has to be inside this parenthesis in example 1 to make that part 0? Anyone?
Three minus three.
What does x have to be then? That's right.
3.
Okay, so look, here's what, and you are absolutely correct. Was that you, Marissa?
Yes.
Let's take a look at this problem here in more detail. They said f of x equals -2, open parentheses, x minus 3 squared plus 8. If I said x is 3, and I put it in here, you get 0. Now, what is f of x really? Does anybody know what f of x is?
Why?
It is y. So now the equation, by simply putting in 3, is what you have here. So if x is 3, what is y? Based on this equation,
8.
8.
it is 8.
8.
And that's what they're trying to teach you. They're trying to say that if you make your x 3, the y is 8. And that will be the vertex. Let's see if that's so. And that's why they call it standard form. Now, somewhere along here, there's the graph. And now look where the vertex is. If you look at the axis of symmetry, it's the 3. The vertex actual point is 3, 8. And that will be the case on every example. If we put this in our calculator, we will get the same thing as they have. So I don't want to do that. But what I'd like to put in the calculator is a positive 2, x minus 3 squared plus 8. Can somebody tell me what will happen if I write that equation? And that'll be this. This is what you have for the original equation. To clean it up, you had f of x equals 2 x minus 3 squared plus 8. And you got something like this. Now, if I give you this, the exact same equation almost, what are we going to get? Can somebody tell me what is the difference do you see between these two equations?
It's gonna cup like up.
You mean like this?
Yeah.
100%. Yeah, that's right. Lillian and you. So let's just prove it. Let's see if it does. This will help you tremendously on the test. Why? Because they give you usually 2 examples. So you'll be able to get it down to 2 possible choices. It means you have a 50-50 chance. So we get this thing to come on again. We clear that out. Clear this one out. So I'm not going to graph the other part. I'm simply going to give you the positive one. F of x is y. It's already in that format, y. I'm going to put a positive 2, open parentheses, x minus 3, upper arrow, square it, push it out, and plus 8. And I'm going to graph it. Oh, it's way up there. You can see barely tip because it's up 2, 4, 5, 6, 8. But you can see the tip of it. Now we could change this so you could see it more. We'll do our windows and we'll say, we'll go down here and change the Y to 20 and just hit graph again. And it'll move it. There you go. Now you can see it better. We just changed the perception. Yes? Does that make sense?
Yeah, it makes sense.
Okay, so now I'm going to go back, change the windows, set it up like it would be normally. -10, excuse me, +10. And I'll just go back. I guess I could do graph again, and it'll show it way up at the tip again. You'll be able to see it come down just to 2 spots. There it is. Okay. So I'm hoping you're getting the idea of what happens. So, is there a question? I can't see a hand because I've got the screen in front of me. Does someone have a question? Okay, so in this example, they want us to tell you a number of things. One is the vertex. This is somebody asking something? Anybody?
It doesn't look like it. I think it's between them.
Oh. Okay, so hold on for a second. Who's ever pinging each other? I'm getting those pings. I'm sorry. We're really going to work hard on this example. So to find the vertex, whatever makes that parentheses 0. The first question is, does it open up or down? We know it does not hold water because the leading coefficient is negative. So that's number 1. Find the vertex. You find the vertex by making the x 0, correction, by putting a number in there that makes that parentheses 0, and that's 3. If x is 3, then y is 8, so that's how they get the vertex. Step 3, find the x-intercepts. That's the hardest thing to do. Look at step 3. In step 3, you're trying to get x by itself. So the first thing they do is they multiply everything by a -2, or they put that -2 to the other side. So it becomes 2 parentheses x minus 3 squared equals 8. Then they divide everything by 2. Then they get x minus 3 squared equals 4. They take the square root of both sides. You get x minus 3 equals 2, or x minus 3 equals -2. Now here is the part. That part, most students somewhat get confused. How come it's plus or minus? And the answer is this. If I give you x in parentheses squared equals 9, to find the solution, you have to take the square root of both sides. If this number matches this number, you get whatever's inside, that's x. But if you take the square to the left, you got to take the square to the right, which gives you 3. but the answer is always plus or minus when you take a square root. Again, why? X squared equals 9. We know that if you plug 3 in there, or if you plug -3 in there, it's going to be 9. So the mathematical principle is that anytime you have an x squared something equals like 25, it's always going to be plus or minus whatever the number might be. In this case, it's 5. So that should explain that part of the problem. That's number 3. Now, the other thing is the y-intercept. If you make x 0 on a graph, that means if we build a graph and you have an equation, whatever the equation is, if the x is 0, that's the 0 part. The y is whatever's left over in the equation. So if I have x squared plus 3 equals y, if the x is 0 in this case, y would equal then 3. And why is it? That's always the y-intercept. A y-intercept always has to have a 0 in the x position and a number in this, in the y position. So going back to the problem, this is very easy then. And this is one of the hardest ones. You simply put 0 in for x. So let me put this in the equation again, so you can see what I'm talking about. It's not on that page in the book, but it will be on the next one. But I think it's better to just show you. So here's the original equation. F of x, which is y, equals a -2 times x minus 3 squared plus 8. Now, if we put in 0 for this position, so in our ordered pair, that we have a 0 in the x, we now have y equals -2 times a -3 squared plus 8. Because 0 minus 3 gives you -3. Now we have -2 times 9 plus 8. Now we have y equals a -18 plus 8. Then y equals a -10. So the y-intercept is 0, -10. That means it's down here somewhere. Let's see. Does that make sense to anyone?
I think so.
So let's take a look again at the book if it doesn't. Lillian, I think appreciate you at least speaking up. At least means you can hear me. So again, if you put, let's go to the next page. If you put 0, step 4, in all the equations, you can see they call it f of 0 because that's what x is 0. You get, just like I showed you in the equation right in step 4, -10. Going back a page, you'll see 0, -10 right there where it intersects the y. And that's called your y-intercept. Now you have the vertex, the x-intercepts, and the y-intercept. Let me show you one other thing. I want to beat this problem to death. Let's go back to our calculator. And somewhere in there we have the original equation. Not quite. -2, open parentheses, x minus 3 close parentheses, upper arrow squared, push it out, and then plus 8. Well, that didn't work so good. Trying to get there. Oh, man. Sorry about this. I took the hard way to do it. There it is, plus 8. So here's the equation. Now, you and I graphed it. We saw that. Looks like this. Let's say we wanted to know all these intercepts. You can simply go to second table and look for all the intercepts. Look at right down here is the y-intercept. Why? Because the x is 0 and the y is -10. Look at the x-intercept. 1, 0. And what was the other intercept? Did anybody remember? Let's take a look at the graph. It's down here. 1, 2, 3, 4. Let's see if we have it. There it is. Well, it doesn't show it, does it? 0, -10, 1, 0.
It's 5-0.
Ah, there it is, 5, 0. That's great. Now, here's the other thing. Sometimes you're going to have fractions. If you're still not happy about trusting your table on your calculator, because if it doesn't have a 0, what can you do? Well, you can use trace. So we'll go back to our graph, hit trace. It's right here. And push it up until you get that spot. Now, we can get pretty close. And it's almost 1, 0. And if you had to guess on the test, I mean, you could probably get pretty close to guessing. You could guess the vertex too. That's about the vertex. And so on. We go all the way down the other side. And whatever the test options are, this is supposed to be what someone said 5, 0. And look, it came out perfect, 5, 0. The trace is hard to move sometimes. But as long as you can graph it, you can get all these answers. Well, Lillian, was that you?
Yes, sir.
You did good. So now I'm going to do one more of these, and then we're going to move on. Look at number 2. You should be able to tell me, does this thing hold water or not?
It does.
Yeah, it does, because in front of the parentheses is a +1, not a negative, so it holds water. What is the vertex, anyone? To get the vertex, you make the x what inside there 0. So what does x have to be? Inside the parentheses, what does x have to be?
-3.
Okay, if x is -3, then what does y become?
1.
Yep, that's that answer for that. There's -3, 1, that's 3. You can find the vertexes, but look it. Or the zeros for the x. look at the graph on the left. It doesn't intercept it. So look, they're imaginary numbers, I, because there is no such thing as a square root of -1. Well, there is, but the square root of -1 is an imaginary number. So it doesn't touch. Now, how do you get the y-intercept? Well, let's go back to the original equation. If you put 0 in for x, you get 3 squared. That's 9 plus 1 is 10. Look, there it is. 0, 10. So I hope you can at least get the y-intercept. To get the y-intercept, remember you have to make x 0. If x is 0 inside the parentheses, then you simply have 3. 3 squared is 9. 9 plus 1 is 10. And so you have the ordered pair 0, 10. And there it is, 0, 10. That's the y-intercept. Does any of number 2 make sense?
It does to me.
Yeah, I get it.
Good deal. So let me see what we want to do in terms of moving on. Now, the vertex can be calculated in a shortcut. This is pretty cool for like finding the height of a punter's kick. And this is the formula that they use like for the Dallas Cowboys, but it's on computer. So look, the x of the vertex is a -b over 2a. So let's look at example 3. The number in front of the x squared is the a, which is a -1. The number in front of the x is -2. That's your b. And c is 1, but we don't use that. So if you look at this, step number 2 says, with regard to the formula, you have a -b over 2a. Well, your b is a -2. 2 times a is 2 times a -1. And then you have a negative sign in front of it because that's the original equation. 2 over 2 is 1, and then you have the negative sign. The signs might fool you, but simply put the b, in this case is a -2, over the a, which is a -1. -1 times 2 is -2. So you have -2 over -2, and you end up with -1. So this is your x. Now, if you figure out your x for the vertex, how do you get the y? Exactly. Let me show you how simple this is. Some people are saying, what? What does that mean? I don't get it. This is the equation you have. Equation is -b over 2a. We got that to be a -1. Why? You had f of x equals a -x squared minus 2x plus 1. In order to get y, this gives us our x. So we simply plug this into the equation. So you have a -1 squared is 1, so it gives you -1. -1 here times -2 gives you +2. Then you have the +1 at the very end. That's a plus, that's a 1. If you add these all up, you get 2. So you get -1, 2. I may not have explained it very well, but this is your x, and you plug it into x in all the x positions. And once you do that, you get your y. And your y in this case is 2. So let's see. So they plugged in the -1 right above step 3. They put in -1 in all those positions, and they got 2. Now, finding the x-intercepts. The original equation is just as we said. What you're using now is FOIL. You have a -x² minus 2x plus y, and this is equal to f of x. But in f of x, we say it's equal to 0. But we cannot use the FOIL because the leading coefficient is negative. So we multiply everything by -1. A -1 times 0 is still 0. This now becomes a positive x². This becomes a positive 2x. And this becomes a -1. Now you have to FOIL it. Two numbers multiplied together equal -1, and when added together equal 2. I don't know if there's two numbers that do that. I don't think so. Let's take a look. So it might be imaginary again. Let's take a look. What they do here is instead of solving this equation using FOIL, they're going to use the quadratic equation. You can see that because they pulled out an A, a B, and a C. In doing that, this is what they get. This is a matter of using the quadratic equation, plugging those numbers in for A, B, and C into this equation. So if we go back to the equation, if we go back to the original equation here, this is your A, this is your B, and this is your C. So for the quadratic equation, the A equals a -1, the B equals a -2, and the C is equal to 1. Once you have these three pieces of the puzzle, you plug it into the equation. -b plus or minus square root of b squared minus 4ac all over 2a. Now, you don't need to worry about the formula because you'll be able to take notes and have it. The question is, can you plug these numbers into the right spots? And hopefully you can. And really, class, that is the lesson for tonight. But let me look on further. I think there's a real world problem they want us to do. Let's see, it is. So if you look at example 4, two things you should be able to tell me right away. Does it hold water or does it not?
No.
Okay, what is the y-intercept? You should be able to look at it right away and just say, boom, it's this. The y-intercept occurs when you make your x 0.
The 13.
-13 is correct. So the y-intercept is 0, -13. Now, if you know those two things, I mean, you hardly can fail the test because they're going to give you a couple options. Two graphs going up, two graphs going down. -13 tells you where it intercepts. You can find the vertex the same way. -b over 2a and plug it in. I mean, it's just too easy. Your b is 6. 2a is going to be 2 times the -3. And there they do it again for you. -b over 2a, they get 1. They plug it in, boom. Now, this is the last problem for the night. This is a real world use of this. So they give you this equation. It's negative. So it doesn't hold water. So it makes sense. Why does it make sense? For this reason. I'll kind of make a joke out of it. Have you ever seen a football player kick a ball where it goes down and then comes up? No. Most players, when they kick a football, will kick it and it'll go up like this and then come down. Now, they usually kick it somewhere about here. This would be the vertex here, and this would be the distance it goes. Now, let me share with you, not everything is as it seems. This is your X, and this is your Y. Where this guy kicks the football right above the ground is when you make X 0. So let's go to the guy in the book. He's kicking the football. If you make all your X's 0, how high off the ground does he kick the ball? Anybody tell me?
It's the 2.
2.
2 feet, of course, because X is 0. Look where he's kicking it. Look at the picture, 3-7. So that's that. What is the maximum height of the punt? That's the vertex. How do you calculate the vertex? I mean, I'm stumped. How do we calculate that? We did it, remember? We found the X for the vertex. It's a negative B over 2A. So if you take a negative B, that's 1.18, because there it says your B. 2 times A is 2 times a negative 0.01. If you put that number in your calculator, you're going to get 59. Put 1.18 over 2 times 0.01. Let me do that with you right here real quick. It's hard to believe they teach me to teach you this so easy. So all we're going to do is take 1.18 divided by 2 times 0.01 and hit our answer. 0.0059, which is 59. Now, let me share with you what happened. Here's what I should have done. Watch this. It's not put in the calculator correctly. That's why you see what you see. We're going to divide it by, I'm going to open up parentheses now. Put in 2 times 0.01. Ah, there's your 59. Why? What happened? The calculator read the 2 separately. It has to read the whole bottom as one number. So that's 59. Now, what does that mean? What was the X again? Or is this the X? Well, let's go back. The X is 59. That's what we just found. So that means this. When the guy kicks the football, the X part is this. Right here. That's 59. So this ordered pair right here where the vertex is 59 and we don't know what the y is. How do we calculate the y? We put 59 in for the x. So let's go back. And they do. Look at the line right here, right below. They put in negative 0.01, 59 squared. So, and it's 36.81. So our x here, 59, the y is 36.81. Now, let me ask you, is this a good punt or not? Can anybody tell me? Can you tell me so far if this is a good punt?
I would say it's all right. It's not that great.
It's really not good at all. That's right. It's 59 feet high, excuse me, long so far at this point, and 36.81 feet high. That's not very high. I mean, the professional football players are kicking punts where it's hitting the signage at Cowboy Stadium. So now let's do the next part. How far does this thing go? Well, someone said, well, you just double 59 and 59. It goes something. No, that's not how it works. These are your x-intercepts. Now, you could put this in your calculator and you could see where it hits. Probably that's what I would do. But let's do it mechanically. So when you put in your A, your B, you notice you identify the A, B, and C. Look at the bubbles on the left. The A is negative 0.01, B is 1.18, C is 2. So you get two answers, always plus or minus, remember? One is a negative 1.7, the other one's 119.7. Now, think about this. You're saying, man, 119.7 right here. Man, that's tremendous distance. This is what? Feet. In football, we play by yards. So if you take your calculator and really want to know if this is a good punt, you take 119.7, divide it by 3 in yards.
Like 39 point something yards, right?
Yeah, you wouldn't even make college in a punt like that. If you kicked a 39 or 40-yard punt, you could maybe play high school, but that's it. And that's the lesson for today. Let me go over again the tenets to see if I missed anybody. I tried to go over a little bit of the homework. I gave you a clue to some of the folks that had got it correct or appeared like they were going on the right direction. You should be willing to help folks, though, because it's a matter of learning. I have to give grades to this class. I'll probably do it tomorrow. I'm pretty tired tonight, but I will probably do it tomorrow. It will be hard to give anybody a bad grade except for those who I don't really know. And what I mean by I don't know, I keep data on all you guys by talking, by the pluses and minuses and stuff like that. If so, you should be pretty good. And those folks that came over and washed my car the other day, no, I'm just kidding. That's a joke. Just kidding. Nobody came over and washed my car. So Amanda, do you have anything for me?
No, thank you.
Okay, if anybody has any questions or wants to put their hat for a study buddy, there's the chat room, discussion board. So I want you to do that. Please don't call me and say, Doc Wick, can you be my study buddy? I can't. So if you don't have anything, again, thank you for coming on, Amanda, and I appreciate you. Hasta la vista to you.
Thank you.
Let me also go over who I do not have. Jennifer, my medical assistant, I don't have her. Let's see who else. Vanessa Cantu, are you here? Oh, Vanessa. Lexa. No, Lexa. How about Miss Gillis? Mr. and Mrs. Gillis. Jordan. Jordan. Going down further. Angelica Moreno. Angelica, are you here? First class missed. Angelica. Gabriel Mulvaney. Venancio, are you here? Dylan.
I'm right here.
I got you, Dylan.
Thank you.
Joshua Cheho. Oh, Joshua. So Dylan, I don't have anything for you. Are you good?
Yeah.
Edith, Emma.
I'm all good, thank you.
Okay, what about you, Edith? No, Edith. Erica, how about you? No, Erica. Holly, how about you? No, Holly.
I'm okay, thank you.
All right, bye-bye, Holly. Hunter, you stay on. Indira.
I'm good, thank you. Good night.
Good night, Indira. Jamie.
I'm good, thank you. Have a good night.
Good night too.
I'm
Lillian.
good. I'm good, thank you.
Edith, you good?
Yes, sir.
Okay, you're good then. Lillian, are you still good? Are you out there? Lillian or Jamie?
Yeah, I think I'm okay for tonight.
Okay, good deal. Jamie, you good?
Yeah, I'm good, thanks.
Good night. Marissa.
Yes, I'm okay. Thank you.
Eric or Edith, are you there still? How about Monica?
Have a good night. Thank you.
Good night, Monica. Reba, Rebecca.
I'm good, thank you.
Bye.
I'm good. Good night.
Good night. Bye, Ryan. Are you there?
Yeah, I'm here.
All right, Sharon, are you there?
Yes, sir. Good night.
Good night.
Have a
Ryan,
good
did
night.
you have some?
No, I'm
Thank
good.
you, Ryan.
Thanks.
Good night, you all. Okay, going back up to the folks that didn't respond. Edith, are you there? Edith or
No.
Sharon or Ryan, are you good? Erica Whitehead, are you there? All right, Hunter, hasta la vista. Thank you. Yes. Bye, Erica. Yeah, because it makes the car cheaper. No, it's rounded to the nearest dollar. So what? Exactamundo.
Uh-huh.
Good night.
I got it correct. I got it correct.
Sharon, great for you. Good for you.
Mm-hmm.
I'm
Thank
proud
you.
of you. Proud of you.
Mm-hmm.
All right.
Thank you.
Good night. Good night.
Uh-huh. Hope you're a very good one.
Thank you.
Mm-hmm.